Alright, this is the solution for RHBL 3, okay, the one that you did yesterday. Now, quite a few of you have problems with this particular worksheet, so I'm doing a video to go through. If you know how to do, let's say certain questions, right, you can just fast forward this video, alright? Now, question number 1A, you are given that the sine of an angle is this one. Now, what do they mean by the sine of an angle is this one? Okay, what they mean is, let's say like sine, then the angle, let's say it's theta, right? They're trying to tell you that sine theta is equals to 0.453. That's what they're trying to tell you. Okay, now, I think everybody should understand this first sentence. Now they say give two possible values for the angle in degrees. Okay, so you learn in radian measure, okay, what we did this week, that angles can be in degrees or radians, right? And I mentioned in class that radians actually is the mathematically correct, accurate way to do it. But never mind, since through history we've been using degrees, we will use degrees. Okay, so in this particular question, we are not going to touch on radian. Okay, anyway, that is not in your WA also. Yeah, you're not tested on that. Okay, so you're just tested on 3 goals. So just focus on degrees. Make sure that your calculator mode is in degrees. Okay, if you don't know how to change your calculator mode to degrees, please PM me. Now, the confusing thing is, I think some of you don't know why there are two possible values for this. Now, when you press calculator, in order to find this theta, this angle, right, you sine inverse both sides. This sine will disappear when you sine inverse both sides. But on the right hand side, you will have this sine inverse of this particular number 0.453. Now, when you press this on your calculator, the calculator will actually give you this particular value. Okay, actually is give me a minute. Inverse sine is 26.936. So it's 26.936. Okay, but as we mentioned in class, alright, if this angle, this acute angle, 26.936, right? Okay, this angle is so-called adjacent to this other angle, which is 153. You take 180, that means you take 180 minus this, you should get 153.064. Okay, you double check whether it's correct or not. Okay, let me check. 156.064. Yeah, correct. Okay. Now, if you just press calculator, you press sine 153.064, right? You'll get a certain answer. Okay. You will find that when you press sine 26.936, you will also get this same answer. Exactly the same. Even the sign is the same. The meaning positive, they are both positive. Okay, so we already explained in class why this is so. Okay, so I will not go through now. Okay, so can you see that the sine of this particular angle is the same as the sine of this other angle, so-called adjacent angle. So as long as two angles they add up to 180 degrees, right? The sine of this angle will be the same as the sine of this angle. Okay, that is why there are two possible values for this particular angle that they're talking about. So how do I do it? Very simple. You just press calculator to get this first answer, which is an acute angle. Then you take 180 minus this whatever answer you get here in 5SF. Okay, then there'll be your other angle. Of course, final answer, you leave it to 1 dp. Okay, not 3 sm, you see. This one is 1 dp, right? This one is 1 dp. Okay, it's not 3 sm. Okay, so I hope this is clear. Alright, so this is for trigo ratio. Okay, for acute, this is acute, small cube angle, right? And this is obtuse angle. Okay, and as I mentioned in class, whether they draw the angle like that, this way or the other way, it's the same old story. As long as this angle and this angle, they add up to 180 degrees, the sine of this and the sine of this, they are equal. Okay, yeah, so I am done with this question. I'm going to move on to the next one. I'm going to erase all this. Now, if you read the next question, they are asking you questions based on this given triangle here. Okay, the part where I'm erasing now. Okay, so you focus on this triangle. We are done with this already, so don't look at this anymore. Okay, we have a triangle PQR with vertices. Vertices means the corner, the sharp point here. Okay, so these are all the vertices. So you just check lah. Just check whether your diagram is fully labeled. Okay, correct. Then now they say without the use of a calculator. That means you cannot, like just now my part 1, right? I go and do this sine inverse 0.453. Correct? I go and do this, right? Cannot you cannot do this here. When they say without use of a calculator, means you cannot use a calculator. Alright? You can use a calculator to help you check answer and all that to help you get certain answer, but you basically need to show working. This without use of calculator means you need to show working. Okay, so what I'm going to show you now is this. They want you to find cosine of PQR. Okay, cosine of PQR. Okay, now where is PQR? It's here, right? It's here. Hey, but then we have a problem. We have a very big problem. The problem is that this triangle that PQR belongs to, okay, is, wait, where is it? Okay, trying to change color. Never mind. Okay, is it changed already? Okay, so this PQR, this blue triangle, right? It's not a right angle triangle. So if it's not a right angle triangle, that's how you would say, oh, then I use sine rule, cosine rule. But cannot. Okay, you know why? Because you don't know this length, you don't know this length, but you can find using your length formula and all that, but no, there is a much because if you try to find this using your length formula and all that, right, then you're using calculator already, because you have square root, you see, and then you say without using calculator. Alright, so what should you do? This is what we do. You extend this line, right? Remember, if I know this angle, okay, then this fella is the friend of this angle, right? Because it add up to 180 degrees. Okay, so what is the benefit of extending this line to make it 180 degrees? The benefit is that I can get a right angle triangle on this side. Okay, I hope you remember the cosine of these okay, wait, right here, cosine of these PQR, right, is equals to minus, remember only sine has the same sign, tangent and cosine, you just put a minus, but the value is the same. Okay, later I will talk about it more. So it's something over something. Okay, so let me just give this a name. I call it theta. So it's minus cos theta. Correct? This cos theta you can actually find. Then you ask me, how can I find? Yes, you can find. How? Okay, so you see, this is your x value, this is your y value, right? This minus 1 is x, this y, 7 is y. Okay, then You see here, isn't this minus 1? Huh? Okay, and isn't this 7? Alright, and if I know this point, isn't this x, y? So isn't this 11? And isn't this minus 1? Okay, and isn't this I mean this x is 11, which is here already, right? Then isn't this 2? Okay, now once you know all these, you will be able to find the coordinates of this point already. Okay, but I'm not really interested in the coordinates, I'm interested, okay, never mind, I just write the coordinates now. I'm interested in this length. Okay, and I'm interested in this length. Alright, because this is my right angle triangle. If I know this and I know this, I can find this PQ. So this is what I'm going to do. So I label this point first. What do you think is the coordinates of this point? Okay, so we have the x and the y, correct? The first number is x, so it's 11. Y is 7. Oh, I see. Okay, that means to get from minus 1, I'm here now. Okay, wait, let me, you think about it. I'm here now. I want to get to here. Okay, from minus 1, I want to, minus 1 to here is 1 unit, right? 1 unit, right? Then here to here is 11 units, right? So altogether, right, this length is 12 units. Okay, this length meaning this length, this length. I'm trying to find the sides of the right angle triangle. Alright, now I found this already. Very happy, very happy. Okay, now I'm going to find this part here. Now this part here, very simple. I know that this is 7, right? This 7, and now here is 2. That will tell me that this distance or this length, which is parallel to this, okay, is 5. Okay, now because I need to find cosine theta, cosine theta, right, is adjacent over hypotenuse. This is opposite, right? Opposite, I'm not interested lah. But if they ask me for tangent, then I'll be interested lah. But now I need to find PQ. Correct or not? I need to find this PQ. I'm focusing on this red triangle now, because it is a right angle triangle that I can use to help me find this angle. Okay? Now, how do I find this particular PQ? You just use your PQ square, hypotenuse square. Hypotenuse is alone, okay? Equals to 12 square plus 5 square. So your PQ is this. Then you say, I need to use calculator. Then just now you say you cannot use calculator. Okay. You can use like mental to calculate this, but you can also use calculator. But what they mean by without using calculator, right, is if you immediately go and press calculator and then find this angle, right, then you will end up with some decimal places and all that, then it is wrong already lah. So what they want you to do without using calculator, right, is they want you, number 1, to show step-by-step working. Okay? Number 2, they don't want you to immediately press calculator and then get the answer without showing it in the exact form. That means without doing all this that I'm doing lah. Okay? So now I have my this 13 already, right? Oh, then I know that these This minus is still minus here, right? But this cosine theta, what is cosine theta now? Cosine theta is adjacent, which is 5, over hypotenuse, is hypotenuse, which is 13, okay? 13. So that's your answer, lor. Okay? That's how you get this, Alright, Okay, so you just show things like that, then you get the answer already. Okay? Now, I'm going to, because similar question is found here, something like what we have just gone through. These kind of questions are called trigo ratios. Okay? You learned it last year. Now, I'm going to skip the rest and I come straight to number 7 because these two are similar types of questions. Okay, later I'll go back to the rest. Now, in the diagram below, BCD is a straight line. So you just check, okay? All these question, you just double check that, oh, my diagram, I understand what it's trying to tell me. And all these, you just check that, oh, yeah, they're labeled, AC, yes. Oh, this one is isosceles. Then you label here, isosceles, so that you know that it is isosceles, okay? Because after reading the question, right, most of the time all of you will just focus on the diagram. You will just ignore this. So I want you in the first step, check that your diagram is updated. Okay, it's an updated diagram. Alright, so if any measurement is missing from this diagram, you just add in. Alright, now prove that ABC is a right angle. They want you to show that this is a right angle. Then of course you will say, of course it looks like a right angle. No, you cannot assume that it's a right angle. And anyway, now they're asking you to prove. Okay, so how do you prove? Now some of you will do this, some of you will do this. Don't do this. You do this is straight away 0 already. You will do this. Oh, hypotenuse square is equals to 6 square. The other two sides square, then you add together, right? Okay, many of you will do this. Oh, this one 100. Oh, this one 36. 64. So 100 equal 100. Now, this type of working is totally unacceptable. Okay, and it makes no sense at all. 100 equal 100, right? No meaning one, no meaning. Okay, so how? Then you ask me, then how? No meaning. Then what should I do? Okay, you must do it like that. Okay, you first of all say. That means you're going to find the hypotenuse. If this is a right angle, then this is a hypotenuse, right? You're going to find your hypotenuse square. You find out what's the value. Okay, then you write here, one line. Okay, don't do like that, don't do like that. Okay, this is our marking scheme. We do like that is because we understand what's going on. But when you do presentation to the marker, right, they want you to do in this way. Okay, then now you tell people, I'm squaring this side, AB square, plus the other BC square. Okay, and I'm trying to find out whether the value is also 100 or not. And of course, you can press calculator and oh, these two are the same. Then you just say, since AC square equals to AB square plus BC square. That means since the hypotenuse, when you square it, right, is equals to the square, the sum of the square of the two other sides. Then by converse means the reverse. Okay, converse of Pythagoras theorem. ABC is the right angle, finish. Okay, so that's how you do it. This one not acceptable. Okay, so that's how you do this particular part. Okay, now if you don't know how to show during the exam, never mind. Okay, never mind. You just make use of the fact that ABC is a right angle triangle. That means for your part B, right, you can safely state or use the fact that ABC is a straight line. ABC is a right angle triangle. Okay, so let's see what they want us to do for part B. Tangent ADC. You see, this kind of question, right, is the same as just now your number 1. The Tuakaso kind of question. Okay, it's the same as your this kind of question, yeah? Okay, now we go back to number 7. Okay, now number 7, you see here, without using a calculator. So what do they mean? They say tangent ADC, right? ADC. So what they're trying to tell you is you cannot go and find this angle using Tuakaso, then find this angle and use 180 minus this. Cannot, because when you try and find this angle you will have to use inverse or cosine, inverse sine or whatever, right? Then you're using calculator to get all those non-exact kind of values. So it's not this method already. You have to show this kind of straightforward exact values, okay, in your working, right? Then you get the marks, okay? So how to do it? Basically it's very simple, Tangent ADC, right? Where is ADC? You locate the angle first. Here, right? And this angle can either belong to this triangle, the non-right angle triangle, or this triangle, correct? So I'm going to make it belong to the right angle triangle, because right angle triangle I can easily do without using any calculator. Okay? And they want tangent, so I need to know my opposite. Do I know? Yes, very good. I know it's 6. Do I know hypotenuse? I'm not interested, so I don't label. Okay, anyway, it's not given to me, you see, so no point. Now I need my adjacent. My adjacent is 18. Correct? Then I can find my tangent ADC already, because it is just opposite over adjacent. Don't leave your answer like that. In mathematics, right, we always reduce to the simplest form. If you don't know how to reduce to the simplest form, how? Press calculator. On your calculator, there's this function, right? You just press 6 over 18. You press equal. They will tell you it's 1/3. Finish. Okay? So that's how you do this particular question. Okay? Finish. Very easy. Now we go to the next one. Now, is there anything to update on your diagram? Okay. For this question, you don't update anything, because this tangent ADC, right, is not equals to angle ADC, this red angle. It's the tangent of this angle that they want you to find, and rightly so, it is 1/3. Okay, so we are not finding this. Hope you are clear. Okay, now we go on to part 2, sine ACD. Where is sine ACD? Okay, I get rid of this. ACD, oh dear. ACD belongs to this fella, which is this non-right angle triangle, right? It's not a right angle triangle. Then you say, oh, non-right angle triangle, I use sine rule. Cannot. Why cannot? Because no friend. Then this fella also no friend. Actually, this fella has a friend, or you can find but just to tell you very simply, because you cannot use calculator, right? So you cannot use sine rule. Are you all clear? Cannot use sine rule, because you cannot use calculator to sine of an angle, sine inverse. Cannot. Okay, so you cannot how? You depend on my good friend lying on the same straight line. As long as this angle and this angle, the red one, add up to 180 degrees, you can safely say that the sine of this angle, which is ACD, is equals to the sine of this other angle, which is ACB. Remember, only sine have the same sign, right? So there's no need to put minus here or whatever. So your answer, right, is just the sine of this angle. That means the sine of this angle is the same as the sine of this angle, okay? So how do I find the sine of this angle? This is my opposite. This is my hypotenuse. So it's 6 over 10. Press calculator, okay? When I say press calculator, I don't mean press sine 6 over 10. No. I mean you press on your calculator, right? 6 over 10. The calculator will tell you that it is 3 over 5. Like that. Okay? Done already. So this one you know how to get. Okay, lastly, what do they want you to find? Cosine ACD. Okay, where is cosine ACD? Let me erase all this first. If you haven't copied, you you go and rewind your whatever YouTube video. Okay, so what is it? Cosine ACD. Okay, cosine ACD. Oh dear, big trouble. Can I use cosine rule? I cannot use cosine rule because I only know this, but I don't know this. And then I don't know this also, so I cannot use cosine rule. In any case, you cannot use cosine rule, sine rule in this kind of question because they say without using a calculator. That means cannot use a calculator. Okay, so cannot. So how? Again, look for your 180 degree friend. 180 degree friend means you use this right angle triangle instead to help you find the answer. Only sine has the same sign, right? So if I want to find cosine ACD, which is this angle here, it is the same as this one, cosine ACB. But, you just, whatever value this is, okay, you just put a minus in front. Okay? This is what I mean, only sine has the same sign. Sine, you don't need to do this. Cosine and tangent, you must. Okay? Now, ACD, this is opposite, right? I'm not interested in opposite. I want the adjacent over the hypotenuse, so it's 8 over 10. Can I leave my answer like that? No, you can't. You must leave it in the simplest form. So it's minus 4 over 5. Okay, so you check answer. That's all. Okay, I will stop this first part of the video. You continue with the next part when you're ready, okay?